Okay, so in this tutorial, I want to talk about using the noise function instead of random. Random is always a great way for anyone beginning with code and processing to generate random numbers, to see variation, to make things modulate and change on the screen. But the problem is that it tends to be very jittery. Maybe it could induce a seizure just from all its flashing. The way people tend to use it in the very beginning, where you might have the size of an ellipse changing or the color rapidly changing over and over again. So this little example here demonstrates what's going on through the noise. That noise itself is kind of calculated in dimensions. So this just, I guess the main point here is that these numbers, instead of being random, they're always taken into account what the number that was generated on the other side of it. So you always get this smooth rippling effect. And the more iterations, or the faster you iterate through it, kind of the larger the distance, the bigger the jumps can be. Let's go ahead and let's make this. Okay, so that's moving like way too fast across the screen. Let's make that offset more like this. Right? So you can see there's a balance to how these are put together. Oops. But anytime that I do this, let's go back to something 0, 0. So this one's going to be really slow. Okay, so you can see just a subtle change as it moves through that space. Anyways, this is just a visual example to talk about how noise works. I want you to get a better sense of how this works by just coding through an example. So let's put this one away. And I've created this quick comparison, so I'm just going to let this run. Try not to look at this too long. So I put a rectangle with rectangle mode center in the very center of my sketch, and I've given it no fill, and I'm using just random, so I have a value called R1, which just gives me a random size. And you can see it's just picking randomly anything between 400 and 0. It doesn't really care that it might pick a number out here and then the next frame pick 0 or something really small. It's just jittering all over the place. So what we want to do is do something similar. We're going to compare how those work together. All right, so for the starters, let's give ourselves something to draw with. And I gave this no fill so that it would sit on top of everything so we could see it. So right inside of here, let's go ahead and put an ellipse. And we're going to do width divided by 2 and height divided by 2. And let's call this one R2 for the radius. Actually, it's the diameter, but we'll just call it R2. Okay. And we need to generate a float for that. Float R2 equals. Now this time what we're going to do is use noise. So noise, the call for that is just noise. And then if we just did, let's just put 10 in there. Let's see what we get. Okay, and let's do it again. Okay, so you can see right now the problem is it's very tiny. You can hardly even see it. So let's look up some stuff about noise. Find in reference. Let's look at this here. Give some information about how those coordinates work. As you read through the documentation, it tells you the resulting value will always be between 0 and 1. And it gives you a little history here. The noise was developed by Ken Perlin in the 80s. This gets used in Maya, Modo, ZBrush, any 3D graphics application, Photoshop, anything that generates kind of smooth, cloudy noise, Brownian textures, things like that. It's all based off this. Okay, so what's happening here is noise is giving us a value, but it's just that noise value just is always between 0 and 1. So the size of our ellipse is really tiny. So let's go ahead and multiply that by 400. All right, so there we have that ellipse right there. And to help see this, let's go ahead and tell this one to be fill of 255. All right, so let's see, remember basically how big that was, right? And it was a different size this time. And a different size. Let's see if we can get a small one. There we go, small one. So every time that I do this, it starts along this random generation of numbers, but then it just sticks right there because imagine a string of numbers, right? So imagine this string of numbers that we have inside of here. And every time we go along, we move a little bit further into a new number and a new number and a new number. And so this appears to be animating in such a way, but what's happening is each number is just moving further down the line as we go. So this one's moving here, here, here. So as we move through this sequence of numbers, we get ups and downs happening that are smooth in their transition. So what we need to do with our other sketch is instead of putting 10 in there, we need to put a number, and we need to slowly move through that sequence of numbers so that we get different sizes. So let's go ahead and stop that. And let's create values. So let's create a float, and we'll just call this X off for like the offset. People tend to use it that way. As a naming convention, we could have X offset, Y offset, Z offset, since it does do three-dimensional noise. But we'll start with X, and we'll say that equals 0. And then down here at the bottom, well, let's just do it underneath here. Let's say X off plus equals, and let's do just 0.1. Okay, and let's put X off right there. All right. So it's beating along pretty fast, and it looks a little jittery, but it is somewhat smooth. I mean, the transitions aren't as crazy as what the rectangle is doing. Let's go ahead and put a 0 in front of that and try it again. All right, so you see we're getting variation. It's going down to even a small size, but every time that it runs through that random, it takes into account the number that was before and the number that's going to be after it, I guess, if you want to think of it that way. But those numbers are always smooth in their transition. The larger the jumps, the more crazy that offset's going to be. So let's do 5.05. So you can see it's smooth but jerky, right? And now let's go to 0.005. This is going to look like it's probably hardly even moving. Right? But it is getting a little bit bigger. Let's cut 1 0 out of that. Let's make it 0.01. Still pretty slow, but you can see it's kind of working. So you can get subtle transitions that are happening. So noise is great. I'm not going to go into how to use this as two-dimensional or three-dimensional noise. You could spend a whole entire semester just dealing with noise and how to generate interesting drawings from that. The main part about noise, two things to remember. One is the value by itself that comes out of noise is always between 0 and 1. So you always have to multiply it by something. And two, you always have to iterate through it. It's basically like picking each step of new numbers as we go through here. So instead of picking the first, second, third, fourth that way, we're using it kind of as fractions of numbers as we move along the sequence of numbers. Very tiny, and we get these smooth transitions. Let's go back to just 0.01. That's probably a better example here. Right? So smooth, but random. Okay, I hope that helps.